Let's look at your 9-3 seminar on writing exponential functions. Do the first 5 questions. If you're working ahead, hang on to your seminar. We will go over those in class, and I expect you to participate. And I expect you to participate on all these problems we're going through. If I call on you, you should be able to answer the question because you've already done it or you watched the video. We're going to be writing exponential functions, and one of the most common exponential functions is compound interest. Compound interest is where you pay interest on your interest. So if you keep money in the bank account, not only do you get interest on the money in your savings account, you get interest on your interest that you paid for the previous year or quarter. That's how credit cards work. So you charge something on your credit card, you pay it off. That's not a credit card, that's a charge card at that point. But if you don't pay everything, you get charged in interest, and it's usually pretty high, like 18%, 20%, some of them a little bit lower. And so if you pay it off, it's no big deal. But if you don't pay it off, then they charge you interest. Now, if you don't pay it off the second month, you get charged more interest, and sometimes you're paying more in interest than you did for the actual object. That's the same thing when you buy a house. When you buy a house, the house may say $500,000, or the loan might be say $500,000. You're going to pay a lot more than $500,000 for that house because you're paying interest on your interest. In fact, what happens is that first month you pay the interest off, so you get a minimum balance or minimum payment. Let's say your house payment is $2,000. Of that $2,000, that first few months, only a little bit of it, like dollars or cents, are going to the actual house. You're paying for the interest. So the interest doesn't get higher and higher. Now, if you miss a month in there, then you get even more in trouble. And so what happens is people will want to pay their house off. They'll pay more than the minimum because anything over that minimum goes directly to the payment of the house, not the interest. Now, when you look at an exponential equation, today we're going to use our form y equals a times b to the x. We're going to write a system of equations with 2 points, and we're going to solve that system. So let's actually do a problem like that. So on example 1, I've got y equals a times b to the x. Notice on my first equation, I've got x and y. So I'm going to replace y with 6. I don't know a. I don't know b. That's why I can't solve it right away. But I know x is 1. Or 6 equals a times b. I'll do the same thing with my second point. I've got y, or x, and y. So I have y equals a times b to the x. Instead of writing y, we're going to write 24. Instead of writing x, I'm going to write 3. So it's a times b cubed. Since I have no exponents in my first equation, let's solve one of these equations, one of these letters. I don't care which one. I'm going to go alphabetical order. I'm going to solve for a. So I'm going to divide both sides by b. So in other words, a equals 6 over b. So what I'm going to do in my equation, instead of writing a, I'm going to write 6 over b times b cubed. Well, b cubed divided by b is b squared, isn't it? So 24 equals 6 b squared. And then I divide both sides by 6. 24, no, well, let's try that again. 24 divided by 6. Let's actually simplify. That's 4. So 4 equals b squared. Take the square root of both sides. b is 2. We could solve that in exponential too, but we're just going to take the square root of both sides. Then, in my equation for a, I'm going to say a equals 6 over b, but b is 2, isn't it? So a is 3. Those are the things I'm going to put into my equation for y equals a times b to the x. Doesn't matter the order you put them in, that's what you're going to get. So y equals a, which is 3, b, which is 2. I'm going to raise that to the x power. And there is your answer. When you do a graph, you do it the same way. The only thing on a graph, we have one more step. We're going to pick 2 points that we know the ordered pairs to. So if I look at my graph here, let me blow it up here, and in my graph, I'm going to pick 2 points. Now, what 2 points do you want to pick? Well, that all depends on what do you see. Well, when I look here, it looks like I'm at 0. Notice I'm counting by 2, so that's 2.5. So I've got this point, which is 0 and 2.5. And then the one is kind of hard to see. Oh, how about -2 and 10? Let's pick those two. Yeah, I could have picked like 1 and 5. That would have worked. Let's pick, not 1 and 5, -1 and 5. Sorry. -1 and 5 I can use. So I'm going to work with these 2 points. If you didn't see 0 and 2.5, you could have maybe picked another point. I'm going to pick those 2 points. So I'm going to go through the same thing. So I'm going to do y equals a times b to the x. Well, in the one with 0, y is 2.5 equals a times b to the 0. Oh, look how pretty that is. We know anything to the 0 power is 1, so a is 2.5. Now let's do the second equation. So y equals a times b to the x. So I'm going to say y. I'm going to substitute 2.5 in for a right away because I know that. So 2.5 times b. Whoops, I didn't write y, did I? Let's write the number for y. So y is 10. So 10 equals 2.5 times b to the -2. And let's divide by 2.5 right away. So 10 divided by 2.5, I should be able to do that in my head, but my brain is not working right now, 4. So 4 equals b to the -2. And I don't like negative exponents, so that's 4 equals 1 over b squared. And then to solve for that, I'll do the reciprocal of both sides, so I get 1/4 equals b squared. So if I take the square root of both sides, b is 1/2 then, isn't it? So I can write my equation, y equals a, which is 2.5, times 1/2 to the x power. Notice it's exponential decay. We haven't talked about that, but notice since it's less than 1/2, it's going down. By asymptote, it's going to the right, so that actually makes sense. Now, when you look at a description, you're just going to say, hey, is this exponential? Is it linear? Are there other things going on that we can do? And we won't have to necessarily use our entire formula, but we won't have to do 2 points necessarily every time to look at that. But we'll take a look at what's going on in the next video.